Okay, here's the question then. We've got this function with these coordinates that are listed on this picture. So there's the picture. And then I'll scroll down now to get the actual question, which is here. Okay, I think that's the question there then. Yeah. Right, I've summarized it here then. So we've got a linear function from here to here and from there to there. Write down the range of f. Well, the highest point here on the picture is 10, and the lowest point is 0, and every point is included in between. So A, the range of f equals, it would be from 0 up to 10, wouldn't it, inclusive? Or we could write that as an inequality. It would be x, if we wanted to, such that x lies between 0 and touches 0 and goes up to and touches 10. So there's the range. Write down f of 0. f of 0, well, f of 0 is that value there. This value here is on the line. This goes from minus 2, 10. It goes down to 2, 0. So every unit it goes along, it goes down, well, it goes from 10 to 0 in 4 units. So 10 over 4, it goes down 10 units as it goes 4 along, which is a gradient, goes down 10, minus 2.5. So if we come forward 2 of those, it would be down 2.5, down another 2.5. So that's down 5, isn't it? So this would be 0 and 5, because we've come down 5 units as we stepped across 2. Okay, so find f of 0. So f of 0 is 5. So I'll put it in here. f of 0 is equal to f, and f0 is 5, and f5 would be here, wouldn't it? So the 5 value, well, you start from 2, 0 and you go up to 6, 4. So the gradient here would be increased by 4 as you come along 4. So the gradient is equal to increase by 4 on the y direction, come across by 4. So the gradient is 1. So for every 1 you go along, you go up 1. So if we come along 5, we go up 5 from 0, which is 5, which is equal to, so it would be 5. And, oh, we're coming from 2, rather, not from 0. And we're going along to 5, so that's 3 units. So we go up 3, don't we? So it'd be 3, wouldn't it? No, we're not going from 0, we're going from 2. Going up to 5, there's 3 units. For every unit we go along, we go up 1. So we go up 3. So we go from 0 in the height to 3 in the height. So that's better. So that's B. G now. G is defined by this. Find G to the minus 1. So let's have a look at that. So here, let's let y equal 4 plus 3x, 5 minus x. So that tells us, move this term up to be with the y. Lots of 5 minus x is equal to 4 plus 3x. Expand the bracket, 5y minus xy, or yx minus y times x, equals 4 plus 3x. Let's move the minus yx to be with the 3. So 3x plus yx will equal 5y minus the 4 then. Move the 4 over. Take the x outside the bracket, so I'll just do that here. 3 plus y. Lots of x. And now we can move this from times down to divide. So that tells us that x, which is here, is equal to this, divided by this. So g minus 1 then Swap the symbols around. The x becomes the y becomes the x. 5x minus 4 over 3 plus x. So that was that. Here x cannot equal minus 3, can't it? So when it, okay, that's good. Okay. Right, because that cannot be non-zero. So solve. So we found that function g minus 1. This goes from domain to a range, and then it doesn't specify the domains and ranges here, so I'm going to leave it as is at the moment. I might check that whether we need the range at the end and the domain, but I'm happy that we've got the actual function here. D. Let's solve the equation then. Gf of x equals 16 is equal to g of f of x. Now f of x is back, equals 16. Okay. Right, f of x. Okay. G minus 1. So when does it equal 16? Okay, so this thing here, g minus 1, let's have a look at that. Because what have we got here? Okay. Okay, let's do that then. So what we can do here is we can do g minus 1. That's what we need to do. So that equals 16. So g minus 1 f of x then will equal g minus 1 of 16. So that g minus 1 of g of f of x rather. So that would tell us that f of x. So we did g minus 1 here, and we did g minus 1 here. So f of x is equal to g minus 1, 16. If we put 16 in here, is equal to 80 minus 4 over 16 plus 3 is 19. 76 over 19 is 4. So basically we need to work out when f of x is equal to 4. If we look back at the top here, when does it equal 4? Well, it equals 4 here. This was the coordinate, wasn't it? 6, 4. So when x is 6 is one of them. So x equals 6. Or x equals 6, or if we get 4, that's not 5. Okay, so let's just go back down again. I've got to be a bit more careful here. F of x equals 4, right? So that was that one. But if I come across here, got another value here presumably. So let's look down here what that would be. So to get a height 4, well, we've come down, how much are we coming down? From 10 to 4. So we've come down 6 units vertically. So we've got to work out this. Okay, so let's call this value A, 4. So 4 minus 10 over A minus minus 2 is A plus 2 must equal the gradient, mustn't it? 4 minus 2.5. So I'm just going to put that down here as a bit of workings. A plus 2 is equal to minus 6 over minus 2.5. Squeeze it in here. A is equal to 6 over 2.5 is 12 over 5, which is 24 over 10, 2.4. Minus 2 is equal to 0.4. Okay, so it's just over here, isn't it, actually, on the positive side. There. So 0.4 then would be the answer here.